Hey everybody, welcome back. Today we're gonna kind of continue on with radicals. Yesterday was a review day, making sure you knew how to reduce radicals, add or subtract radicals, and multiply radicals. Well, now we're gonna have division problems or fractions. So make sure you take out a brand new sheet of paper. And it is April 21st. So you label the title, the top at the label 4-21. And then you write everything down that you see on the board. Anything that goes on the board goes in your notes. And then you'll also try the homework problems tonight. All right, you guys, you're gonna learn a new word. A new vocab word is rationalize. And whenever math people use the word rationalize about radicals, they mean that you have to get rid, it needs to go away, of any radical that is in the denominator. Now, it doesn't just get away from being a fraction, but there's just no more square root in the denominator. Now, how are we gonna do that? So here is number one. We're gonna have a fraction or division problem, rad 2 divided by rad 3. Now, in a fraction, you're allowed to have a radical in the numerator, but you're not allowed to have a radical in the denominator. So what we wanna do is we wanna make a perfect square root, because if you remember from your previous days, when you have a perfect square root, it's no longer a square root. So how do we make a perfect square root? Well, you look at it, and really you just want all of the stuff to come out of the radical and leave nothing inside that's trapped. So if I already have 1, 3 in my problem, what I need is another 3 underneath that square root, and you need to know your multiply rule. Your multiply rule, remember, says that an inside times an inside stays inside. So I need another inside 3. So what I'm gonna do is I'm gonna multiply by a square root of 3. Now, it's not fair to just do that to the denominator, so you also do it to the numerator. And now we can do our multiply rule. So you have to know your multiply rule before you can even clean up fractions. And it states that's an inside times an inside stays inside. So on top, I have square root of 2 times 3. And on bottom, an inside times an inside stays inside. So that's square root of 3 times 3. Well, we look for pairs. And what do we see on bottom is a pair of 3s. So a pair of 3s gets to break outside of the radical. And when you do that, nothing would be left inside. So on the top, you still have a square root symbol. 2 times 3 makes 6. Fraction or division bar. The pair of 3s gets to come out as a single 3, and there's no longer a radical in my denominator. And I did a thing called rationalize. Now, if you have a calculator and you type that in correctly, now you do got to close off the parentheses. So this would be the square root of 2, close the parentheses, divide by the square root of 3, close the parentheses, and get a decimal here. And then if you type this in your calculator, square root of 6, close the parentheses, divide by 3, they'll be the same decimal answer. So all of this work didn't change my number, it just changed its appearance. It's like kind of going to prom maybe. This is just like you in your everyday clothes, and this right here is you all dressed up for prom. Same person or same number, just maybe looks nicer. Okay, let's look at number 2 and see if we can kind of just speed things up. To get rid of a radical in the denominator, you basically need to multiply top and bottom by the radical from the bottom. So we're gonna multiply by rad 5 on top and bottom. Now on top though, we have pieces that don't get to go together. 7 is an outside piece, 5 is an inside piece. So really they just get squished. The outside is 7, square root 5. Now, when you take square root of 5 times square root of 5, you can speed things up. Hopefully you know that there's gonna be a pair. It's gonna be a pair of 5s. So the bottom is just gonna be 5, but I'll show all the work, but as you get better, you'll speed up. You have a square root of an inside times an inside stays inside, but now you have a pair of 5s. A pair of 5s break out as a single 5, and there's nothing that would be trapped underneath that radical. So we're gonna have 7 rad 5 as our numerator, and our denominator is just the number 5, and we no longer have a square root in the bottom or the denominator. Okay, let's try a couple more examples about rationalizing, and we will be doing a second day on this. So tomorrow you're gonna get some more practice. So hopefully you're following along and just, I said baby steps. So number 3, we have 8 rad 5 over 2 rad 7. And then number 4, we're going to have a square root of 4/3. Okay, let's do the work. Whenever we see this problem, there's only one part that math people would consider not nice looking, and it's the radical in the denominator. The 2's not bothering them. You're allowed to have numbers in the bottom. So I'm going to multiply the top and bottom by the radical from the bottom. Now on top, the 8, there's no other outside numbers except for the invisible 1, so 8 times 1 is 8. You have a square root. Inside times inside stays inside. So you could show 5 times 7, or you could just multiply them out. Over the 2 has to stay a 2. But now I have a square root, and I have inside times inside stays inside. But you can pause it here. What's going to happen on the bottom? The pair of 7s is going to get to come outside, and if you look, there's nothing trapped underneath that radical. So the numerator is 8 rad 35 over 2 times 7, and it's 8 rad 35 over 14. Now, this problem could be reduced a little bit. We didn't talk about it today, so right now that's all I want you to put. If maybe somebody who knows a little bit more math, mom, dad, aunt, uncle, brother, sister helping you out, they might not say that's the final answer. Today it will be, but we're going to see how we could have changed that problem a little bit or reduced it more tomorrow, and that's going to be why we're taking 2 days for this stuff. Okay, number 4. The next thing that you have to know is if you take a square root of a fraction, it actually square roots both pieces. So you would first break it up as the square root of 4 over the square root of 3. Next thing, there's a special one up there. Always look for special square roots. The square root of 4 is just the number 2. It's not really a square root at all. So this problem becomes 2 over square root of 3. So always look if a square root is perfect or not. But now we have to do the whole rationalizing thing. We want to get rid of the square root in the bottom. So you multiply by rad 3 on top and bottom. Now let's see if we can speed up the whole bottom now. The top. The outside 2 does not really get to multiply with the inside 3. They just get squished together. And let's see if you can speed up the bottom. Instead of writing a square root with a 3 times a 3, circling 3's and bringing them out, you had a pair of 3's. So there's just a 3 outside the radical and nothing is left in there. And you are done. So today we are starting to learn how to rationalize. Math people do not like radicals in the denominator, so we have to clean it up. Now you're usually going to have a radical in the numerator, right? There's a couple of problems you might see later on that there's not even a radical there, but we for sure cannot have a radical in the denominator. Hope this helps. Please reach out to me on Google Hangouts, Google Chat, Google anything Google Classroom. You could just do post a message on my stream. You can email me. Anything you guys need to help you out, I'm here to help you guys. All right, you guys, here are your 4 homework problems. Make sure you put these on the same sheet of paper and upload them to the Google Doc. Let that zoom. There you go. All right, have a great day, you guys. It's your boy, Mr. P.